Okay, so today we will see the working of N-Channel Depletion Type MOSFET for condition 2. Our condition 2 is that VDS is positive and that is fixed, but VGS is varying from negative to positive. So first we will see what happens when we take VGS to be negative, and then we will see what happens when VGS is taken as positive. So here it is the structure of N-channel depletion type MOSFET. So substrate is of P type, our source and drain are of N plus type material, and the channel is of N type material, and then there is a layer of oxide, then above that there is a layer of metal, and above that we have gate terminal, and source terminal is taken as reference, so its voltage will be considered to be 0. And since here we are not discussing body effect, so body voltage also will be taken as 0. So now let us see what happens when VGS is taken as negative. Okay. Now since Vs equals to 0, so VGS equals to negative means Vg equals to negative. Since Vs equals to 0, that means Vg equals to negative. Now this is the channel, and channel is of N type, so it will contain positive ion with electron, positive ion, electron, and there will be so many such pairs. Now this is source, this is drain is positive, and body is also taken as ground, and this is P substrate. P substrate means it will have negative ion paired with holes, and here we will have our gate terminal, and at gate we are applying negative voltage, so it will be something like this, negative. Okay, so this is channel, this is P substrate, source, drain, and gate terminal, and at gate terminal we are applying negative voltage, so this minus sign indicates that negative voltage. Now here, due to these negative voltage, that is due to this negative voltage, our electrons will get repelled, so our electrons will move towards the bottom, all the electrons, and our holes will be attracted towards the channel. Okay. Now these electrons and these holes will recombine. So the number of electrons in the channel will get depleted as we increase the VGS in negative direction. So I can write that but if we increase VGS in negative direction, that is, we will make our VGS more and more negative, channel will get depleted of electrons, and if channel will get depleted of electrons, that is, there will be less number of electrons, means what? Our current will also decrease. So this will decrease our current. From here I am writing. So current will decrease. Okay. So first we took VGS to be negative. That means Vg equals to negative. That negative voltage will repel those electrons which are in the channel, and that negative voltage will also attract the holes from the p substrate. So the electrons from the channel and the holes from the p substrate will recombine. So channel will start getting depleted of electrons. So if we increase VGS in negative direction, that if we make our VGS to be more and more negative, the electrons will start recombining more and more. That means channel will get depleted of electrons, so current will decrease. Okay. Now what happens if we keep on increasing VGS in negative direction? So let's see that. Let me remove this first. This is source, this is drain, and this is gate. Okay. So I will just remove these. Okay, not let it be. So here we have negative voltage because our VG is negative here, and we will have here positive ions with very less electrons, because most of the electrons have recombined with those holes of p substrate. So let it be here. Some electrons might be there, but it is not necessary. Okay. Now this negative voltage is here and these positive ions are here. So we will have a strong electric field in this direction, positive to negative. This electric field will be so strong that even if any electron from the source tries to move towards the drain, this electric field will move its direction towards the bottom, because we know that electrons move in the opposite direction of electric field. So electric field is in this direction because electric field goes from positive to negative. So electron will move from here to here in the direction opposite to electric field. So this electric field is so strong that our electrons, even if they try to move through the channel towards the drain, they won't be able to. They will just move towards the bottom. So when this electric field becomes so strong, it will become so strong at a certain VGS. Like I told that when we keep on increasing the VGS in the negative direction, so at a certain VGS which is negative, at a certain negative VGS, electric field will be so strong that even if electrons try to move, so let me first remove this. So after this I am writing here that it will be so strong that even if electrons try to go towards the drain from the source side, they won't be able to. And due to this, our current will be zero, because if no electrons will pass from source to drain, current will obviously be zero. So it means that current becomes zero. Okay, so complete thing is that when VGS is negative, electrons from the channel gets repelled towards the bottom, and holes from the P substrate gets attracted towards the channel, and electrons of the channel and holes of the P substrate get recombined together. So electrons in the channel start getting depleted. Because of that depletion of electrons, our current will decrease. Now if we keep on increasing the VGS in the negative direction, our current will keep on decreasing, and there will be a certain negative VGS value for which electric field will be so strong, this electric field, that positive ion and this negative voltage. So this electric field will be so strong that even if electrons try to go towards the drain from the source side, they won't be able to, because it will be moved into this direction. It won't be able to go from here to here. So current becomes zero. And this certain negative VGS is called as pinch-off voltage. Now let me remove this too. So at pinch-off voltage, current becomes zero. And what is pinch-off voltage? Pinch-off voltage is negative value of VGS, negative VGS, at which vertical electric field becomes so strong that electrons are not able to move from source to drain. Okay, now let's see what happens when VGS is positive. So if VGS becomes positive, our VG will be positive, and then this is a channel, and channel is of N type, so it will contain positive ion with electron. And here we will have drain, which will be a positive voltage. Here we will have source, which will be grounded. Here we will have body, which will also be grounded. And here we will have P substrate, which will contain negative ions with holes negative. And in P-type material, we just show that we have negative ions with holes because holes are our majority charge carriers in p-type material, but there are also some electrons, but since they are minority charge carriers, they are less in number, so we don't show, but electrons are present there. So we will just show some of the electrons like this. Now this is our gate terminal, and we will have positive voltage, so here we will have plus. Due to this positive voltage, electrons will be attracted towards it. So whatever electrons are present in P substrate, even if they are less in number, so they will be attracted towards the channel. So the number of electrons in the gate in the channel will increase because of this positive voltage, and if the number of electrons in the channel increases, then this channel gets wider and there will be more current passing. So we can write that positive VGS increases the number of electrons in the channel. This will make the channel wider. And due to this, current will increase. Because channel is like a pipe, like water pipe. The wider the pipe is, more water will flow through it. Similarly, wider the channel is, more current will flow through it. So positive VGS increases the number of electrons in the channel, and this will make the channel wider, and due to this current will increase. So now we will see some of the curves related to these things. Let me move this. So first we will see output characteristic. Output. Because here it is said to be output characteristic because here we will see the curve of ID versus VDS, and ID is output current and VDS is output voltage. So it will look somewhat like this. Let's take in the previous video we saw this curve, but there we saw only for VGS equals to 0. So let us consider it to be VGS equals to 0, this curve. Now if VGS equals to negative, what happens? Our current decreases. So current decreases means the curve will be somewhat like this. Consider it to be -1 volt. Similarly, if we take VGS to be -2 volt. Now, if we take VGS to be +1, you will see curve like this. Because when we take VGS to be positive, our current gets increased. So this is what our output characteristic for N-channel depletion type MOSFET looks like. Now we will see the transfer characteristic. transfer characteristics because here we will see the curve between ID versus VGS. Our ID is output current and VGS is input current. So one is of output, one is of input, so it is named as transfer characteristic. So it is VGS, it is ID. So here we will have our pinch off voltage because pinch off voltage is negative VGS. So in this direction, in the negative direction we will have our pinch off voltage and we will denote it with Vp. So from Vp our current will go like this, increase, increase and increase. So these three curves are for different VDS value, VDS3, VDS2 and VDS1. Sorry. Here VDS3 is greater than VDS2 is greater than VDS1 because for a certain VGS value, like suppose it is a VGS, here we take it to be plus 1 volt. So at a certain VGS value, the current value is highest at VDS3 and it is at VDS2 we will have current value less than VDS3 and greater than VDS1. So our VDS3 will be the highest, VDS2 will be less than VDS3 and VDS1 will be the lowest. So this is our transfer characteristic for ID versus VGS, and this is it for today, and we will discuss P-channel depletion type MOSFET in the next video. Thank you.